Okay.
Okay,
The more dynamic temperature of surface a star is inversely proportional to the wavelength at which maximum rate of emission occurs.
okay. Temperature is inversely proportional to wavelength. Temperature is the thermodynamic temperature of the surface of the star. Wavelength is the wavelength at which maximum emission rate from the star occur. Can join them together lah. Okay, but that is how they give the mark lah. Right, this is always come out lah. Can be any question, but it looks like you have to learn to come to a conclusion, no? Draw a conclusion from the graph. No? Figure 9.1 shows a variation with 1 over d square of the radiant flux intensity F d minus 2 observed for star X, where d is the distance of the observer from the star. 9.2, which is this one, shows the variation with wavelength of the rate of emission of radiation by star X and the sun. Right? The top is the star X and here is the sun. The surface temperature of the sun is 5770 Kelvin. State 3 conclusion about the star that can be drawn from this data. Conclusion can be qualitative or quantitative. Use the space for any working. Right? That usually they leave you some space for you to do working, but it's better to read the list less calculation. Okay, can mark yourself. These are given in your formula sheet. Okay. Surface temperature of star. Right, okay, this is formula to calculate. 710. And know how to calculate the gradient flux intensity equals to gradient. Right? This is your F. This is your D. We change to D rather than R. Okay, some things you can calculate. So take this one out, 1 over D square is this one, F. So this is a gradient. L over 4 pi is a gradient. So gradient, calculate, take a point. Easy to read point. Remember 10 to the power minus 23, 10 to the power 3. And calculate L. So star X has a higher luminosity than the sun. Okay, that one you should be able to come out without much calculation. Star X has a higher temperature than the sun. Then luminosity, less temperature. Choose the easiest one, least calculation, the better. so that I have more time to spend on your paper. Okay. Any comment, anything you want me to explain?
Oh,
Star X is a galaxy. Is in a galaxy that is moving away from the Earth. Suggest we reason how the line for star X in figure 9.2 would appear differently if it had been obtained from data measured from the Earth. Yep. What is your answer?
so I wrote, if observed from the light from star X will be redshifted, since the wavelength at which maximum rate of emissions occur will be greater.
Light from star X is
Yeah,
redshifted.
redshifted.
Okay. That's your first mark. Wavelength of peak emission rate will be greater using observed data. Okay. Define specific acoustic impedance. Okay. What is your definition?
Product of density of medium and speed of ultrasound in that medium.
Product of density and speed of sound in a medium and intensity of medium. Okay, or you can combine them together, product of density of the medium and speed in the medium. Explain how ultrasound are detected by piezoelectric crystal. Okay. We are looking at the answer here.
Ultrasound hit the piezoelectric crystal and cause it to vibrate. And then the vibration will produce EMF.
Ultrasound wave cause crystal to vibrate. Vibration of crystal cause induced EMF across the crystal. Okay. Table 10.1, 10.1 shows the specific acoustic impedance Z for the body tissue, water, and steel. Calculate the intensity reflection coefficient for ultrasound incident in water steel boundary. Water and steel boundary. Go to formula sheet, you can remember so much the better. We are going to calculate this one. It doesn't matter which one is Z1 or Z2. You can identify. Ultimately, you square them, that's all. Take a common factor out, 10 to the power 6. This becomes 40.4, 0.86. Explain without calculation what is likely to happen when ultrasound is incident on the body water boundary. Okay, what would be your answer?
Causes the density reflection coefficient to be 0. And all the sounds
Z value are very similar. So almost all the ultrasound will be transmitted. Right? That means this is very small. almost zero lah. Or almost none of the ultrasound will be reflected. Okay.
Okay.
Okay, we have completed this paper. Let's try the next one. Okay, October, November 2025, 42, 2 hours. The Earth may be considered as a uniform sphere of radius 6.37 times 10 to the power 6 meter. Cambridge is at a point on Earth surface that has a latitude of 2.2 degrees north of the equator, as shown in figure 1.1. As the Earth spins on its axis, Cambridge moves in a circle that is parallel to the equator, but with a smaller radius. Show that the radius of the circle around Cambridge moves at 3.90 times 10 to the power 6 meter. Right? So basically find this length, which is the radius of the circle. Right? This auxiliary angle. Okay, that is the radius R. Okay, now anything not clear?
Okay.
Calculate the speed at which Cambridge move in the circle. So that is how we calculate our R. Period is 24 hours. Same period, same omega. V is 2 pi R over T. Right? This is the circumference of a period, time. Distance divided by time. Right? Put in your value and calculate out. Okay, anything that I need to explain further?
So,
A student of mass 58.96 kilograms stands on the horizontal ground in Cambridge. Determine the magnitude of the resultant force that acts to cause a horizontal motion of the student. Okay, that's the speed that we have calculated for Cambridge. That's the radius at Cambridge. Okay, calculate the centripetal force or resultant force. Put in the value, calculate out. On figure 1.2, draw an arrow to show the direction of the resultant force that acts on the student. That's the resultant force, which is the centripetal force towards the center of the circle. There's a marking scheme. On figure 1.3, draw or label the arrows from the student to show direction of the forces that act on the student to cause the resultant force. Right? Weight is going towards the center of the earth, and the resultant force is going this way. So there must be a contact force going the other way. Okay.
okay.
State Newton's law of gravitation. Okay, try. Have a go without looking.
Gravitational force between 2 point masses is directly proportional to the product of masses and inversely to the square of summation.
Okay. G is directly proportional to the product of the masses. Right? The force between the point mass is important, is inversely proportional to the square of their separation. What is the point mass?
Point mass.
Be a bit louder. What is the point mass?
Is it like the center of gravity?
No. In order to be a point mass, the size of the body must be very much less than the separation. Okay, that means the moon and the earth is a point mass also.
Oh yeah,
But
yeah.
but
Okay,
you are
okay.
standing next to me, then we are no more point mass. So, but since you are further away from me, we are point mass to each other. We can only see each other as a point. No? That's the idea of point mass. One of the basic assumptions of the kinetic theory of the gas is that there are no forces exerted between the molecules of the gas except during collision. State two other basic assumptions of the kinetic theory of gases. Okay, very popular question. What's the answer?
Uh, gas molecules are moving randomly.
Second one.
Collision are completely elastic.
Okay, molecules are in continuous random motion. Molecules have negligible volume compared to volume of the gas or any point. Right? Collision involving molecules are perfectly elastic. And then collision of molecules are instantaneous. Hydrogen gas consists of molecules that each have a mass of 3.4 times 10 to the power minus 27 kilogram. Hydrogen may be considered to be an ideal gas. A spherical balloon contains 0.0160 mole of hydrogen gas at temperature 282 Kelvin. At this temperature, the volume of gas in the balloon is 1.87 times 10 to the power minus 4 meter cube. Determine the pressure of the gas. Okay, what formula they use?
Pressure of the gas.
Be a bit louder.
PV equals nRT. Then you take P equals to nRT over V.
Okay, PV equals nRT, then you just find your P, right? There's your N, there's your R, there's your P, and then your volume, take it down. There's your volume, the volume, get the answer. Estimate the average separation of the hydrogen molecule in the gas. It's not mentioned in the syllabus, but they can push the syllabus to extreme. Previously it's mentioned, but now it's not mentioned in the syllabus. So imagine here, the volume occupied divided by the number of molecules, then cube root it
Oh,
to find the separation. Number of molecules is N times Na. Na is Avogadro's number, right? Number of moles, number, the number of molecules. Volume occupied by one molecule, right? That's the volume of the balloon divided by the number of molecules. So that's the volume occupied by one molecule. Then you assume it's a cube, cube root it. Okay, anything not clear? Use your answer in C part 2 to calculate the average gravitational force between adjacent molecule in hydrogen and oxygen gas. They have given you the mass in the question. So use your formula, put in the value, there is G, there's the mass of hydrogen molecule, hydrogen atom, that's two of them, and there's a separation of the atom. Very small. By considering the weight of the molecule suggests we reason whether your answer in D part 1 is consistent with the assumption of kinetic theory of gases that there are no forces exerted between molecules. The force is so small, so we have to compare with the weight. So weight, you just times 10. So it's about 10 to the power minus 27, 26. Compare with that 10 to the power minus 46. You can see this is too small compared with the weight. Right? So the assumption is supported. State what is meant by two objects in thermal equilibrium.
Zero net thermal energy transfer and same temperature. Two objects staying at the same temperature.
Okay. Key idea is two objects are at the same temperature, no net transfer of thermal energy between them. Figure 3.1, 3.1 show a type of thermometer called the constant volume gas thermometer. The thermometer is used to determine the thermodynamic temperature T of the gas in the glass tube. First thing to realize is that this is very big. So you cannot measure small quantity of liquid. And then there is a line there, right? To measure to keep the volume constant. You adjust this one to keep the volume constant. And do a gas constant. So it's bulky. It takes time to set it up. Not like just not like the mercury thermometer can straight away measure. Yeah, you use it, you have to set it up and then adjust the thing. And then remember that this is an insulator. So the gas takes time to warm up to the temperature of the surrounding. The thermometer is used to determine the thermodynamic temperature T of the gas in the glass bulb. The glass bulb is immersed in an environment in which the temperature could be measured. The height of the movable glass tube then adjusted so that the level of the liquid on the left-hand side aligns with the reference line X marked on the big glass tube. This glass tube. The reference Y is marked on the movable glass tube. That's your Y. And there's your scale. Y is higher than X. As a result, the pressure in the gas is a pressure of the gas in the glass bulb. The difference in height, delta H, between the liquid level at X and H is then measured using the scale. The thermodynamic temperature T of the gas is directly proportional to the pressure of the gas. The pressure is directly proportional to delta H. Okay, they can within your syllabus explain to you even if it's not in the, it doesn't come out in the syllabus, but they can use whatever, whether it's AS, a mixture of AS and As long as they explain to you lah how it works, then you're supposed to know how to use it. Oh. The value of delta H, right, as a delta H, can be used to calculate the pressure of the gas. In order to do this, the gravitational field strength is used along with the property of the liquid. State the property of the liquid that is used to calculate the pressure. Okay, what's the property of the liquid?
Density.
Okay, good. Basically, we are just using this formula from AS. Pressure is delta H rho G. Before measurement of delta H can be made, the glass bulb needs to reach its thermal equilibrium with the environment to which the temperature is to be measured. State two disadvantage of using constant volume gas thermometer to measure temperature. Okay, you want to try?
Because like the thermometer needs a lot of time to like what do you call it the change. But
Takes a lot of time to reach thermal
so you
equilibrium
cannot
with the environment. Okay, second point.
measure like rapid changes in temperatures.
You cannot measure rapid changes in temperature because it takes time to.
Yeah.
Okay, good. Cannot measure rapidly changing temperature. Difficult to set up. Or any others. These are the other points that are acceptable by them. Larger response time. Larger time to reach equilibrium. Right? Is an insulator, the gas. Bulb is also an insulator. Measure equilibrium requires significant transfer of energy. Right? It's huge. So it cannot measure. It has to receive energy from the surrounding. Changes temperature environment be measured. If the liquid measure, if the surrounding temperature or a medium to be measured is a small volume of liquid, going to remove a bit of liquid, a bit of energy from the liquid. So it's going to cause the temperature of liquid to go down. So that's the disadvantage. Change the temperature of the things they want to measure. Cannot measure temperature of small object. Right? Because the bulb is too big. Cannot measure temperature of small quantity of liquid. Bulky, difficult to set up, or difficult to take reading. Scale not calibrated to read temperature. Right? You have to read the scale, and you have to calculate the temperature. That's why it means difficult to take reading. Cannot measure temperature of solid object. You cannot. Right? Because it's a poor conductor. You have to surround it with a liquid or gas. Okay, any comment or anything not clear?
Okay.
Suggest one situation in which constant gas thermometer would be an appropriate type of thermometer to choose in measuring temperature. Yep.
When the temperature is constant for a long time.
Often large mass. Large mass.
Oh, cannot
The
say
idea
like
is
temperature is constant.
the bulb is very large. So if it's a small mass, it's going to
Temperature changes faster.
say again.
No, I thought like so that I mean
Temperature is
the
constant also
thermometer
can
used when yeah, okay.
to calibrate other thermometer in laboratory. Right? You need large mass because the bulb is large already.
Hmm.
Right? Any of this answer is acceptable by the examiner. Level X aligned at 2.31 cm scale at 0 degrees Celsius. Level Y aligned with 8.69 cm at temperature theta. Level Y aligns with 7.83 cm scale. Determine the temperature theta in degrees Celsius. Right? T1, which is this one. Okay. Change in height. This one subtract that. And at temperature T2, right? It's delta H2. So it's this is constant. So 783 minus 23231, 5.52. Then instead of pressure, we can use delta H, right? Pressure is proportional to temperature. We can use T is proportional to delta H. Then you want to find T2, T1, delta H1 times delta H2. Put in the value 373, H2 is H2. Don't have to change to meter because both of them are in cm. Cancel off. Then change it to Celsius. Okay.
Okay.
A cylinder contains a fixed mass of an ideal gas at temperature 2y and volume 6x. Right? That's where it starts. The gas undergo a sequence of changes from its initial state A, that's initial state A, to B, C, D, then finally back to A. Figure 4.2 shows the variation with time of the internal energy of the gas. Right? Internal energy against time. Take the first law of thermodynamics. Okay.
First law of thermodynamics.
Be a bit louder.
The change in initial energy equals the heat supplied to the system plus work done.
Basically, they are just using this formula lah. But the
Yeah.
marking scheme demand slightly different lah.
Oh, is it?
You have to change internal energy equals to work done plus energy transfer by heating. This is new lah. This is the first one. Then after that, you say the increase or gain in internal energy. The gain in internal energy, energy transfer to the system or heat gain by the system. Then this is work done on the system. Right? The key is on the system. Right? Previously, this one is not acceptable lah. The top one. So now you have to add two of them together. Lor. Okay. Any comment?
Nope.
Okay. Understand that if it is high constant temperature, it moves this way. Right? This is isotherm. Whereas if it moves down at constant volume, lower temperature, if it moves to the right, it goes to higher temperature. Right? In constant volume process, where pressure increases, temperature increases, so P is proportional to T. Right? There's constant volume, no work done. In constant pressure process, this constant pressure process where the volume increases, volume increases, there's work done already lah. Temperature of the gas increases, so its volume is proportional to temperature. Because pressure is constant for this part. This part volume is constant. Right? Now, only this formula is given. Using figure 4.1, 4.2, determine the general expression for internal energy U of the gas when it has a pressure P and volume V. Okay, look at A, and look at A. Right? At A, PV is 6x times 2y is 12xy, and internal energy at A, internal energy equals to 18, right? xy is PV over 12, PV over 12, and simplify to get 3 over 2. An ideal gas at thermodynamic temperature T contains N molecules. Use your answer in B part 1 and the equation of state for ideal gas to deduce an expression U in terms of N and T. Identify any symbol used. This one they didn't ask you to use formula lah. Right? This one you are supposed to use the two graph to get your answer lah. And if you are supposed to use formula, then this is the formula that how you get it lah. Internal energy is the total kinetic energy for ideal gas. And this is your manipulate this one then to get your PV, half mv square here. Okay, that's extra knowledge only lah. You're not supposed to use this method lah. Use your answer in D part 1 and the equation of state for ideal gas to reduce. Okay,